In the normal CSPs, the heuristic information or the knowledge about the problem space, is embedded or covered with a set of very hard or strict rules or constraints. So these constraints make the possible values, because each of the variables can take different values, and the number of values that can be associated with the variables will be reduced due to the restricting constraints or conditions available in CSPs. So we cannot take all the values available. We have to take only those values which go with the conditions available or constraints available. So this makes the model of the problem stationary. Why? Because of the rigidness or strictness of the conditions. So this can be treated as inflexible model because the conditions are very tight or strict, which makes the representation of the problem very difficult. So we should have a flexible rules for making the representation fairly easy. That is not the case with classical CSPs or ordinary CSPs, where knowledges are or heuristics are embedded with hard constraints. In the real world scenario, this is not the case. We can dilute the rules according to the demand of the situation. Even though some rules are available for many of the things, we will not be following it as such. When the situation demands, we will be making changes in the constraints. So we have to think of that type of problems instead of purely hard or strict rules applied on the variable set. So in the real world problem, we will be having priority over others on the constraints. Some constraints may have priority over others. We can override the constraints with some other constraints. So this makes us easy for making models that can be applied for different situations instead of a specific situation. With the flexibility of the constraints, we can make a model available for different situations, so that our representation also will be very easy. Then this is another type of CSP, dynamic. Dynamic means changing. Static means constant. So dynamic CSPs can be considered as a series of static CSPs. It is helpful when original design of a problem is modified, mainly due to the set of constraints being considered undergoes changes because of environment. When we use backtracking, we have seen that a system should interact with the environment. That means it should be changing with the environment as the environment demands. So in a dynamic CSP, we have to consider the changes that happens in the environment. With that changes, the set of rules also get changed. So we have to modify the problem. Problem modification means we have to make changes for the constraints also. So in that case, we can say that DCSP, dynamic CSPs, can be seen as a series of static CSPs. Consider a problem or dynamic CSP. Say it is broken up into 5 small constraint satisfying problems. We can say that these 5 small problems as a static CSP, and altogether they form a dynamic CSP. If we are treating this as a series of 5 small problems, then problem 1 can be modified to form problem 2, which is modified to form problem 3, then to 4 and to 5. The problem will be completed only after completing the 5th static CSP. So 1, 2, 3, 4 and 5, when they are treated independently, when they are taken independently, they are of static nature. When one static nature is executed, and which is the formation of a base for formation of the second static CSP, we have a change there. So when we take the whole static CSPs all together, we can say that the static CSP number 1 have been changed into static CSP number 5. There is a good change when we travel from 1, 2, 3, 4 then to 5. So when we consider each one of them, they are called as static CSPs. And when we combine these and treat it as a whole problem, a big problem, we can say it as a dynamic CSP. Here, each one of the CSPs are modification of the earlier one. As I said, 2 is the modification of 1, 3 is the modification of 2, and 5 is the modification of 4. So here it is possible to add or remove variables and constraints. Additions is called as restrictions, imposing restrictions. Removal is relaxations provided. So when we move from one CSP to the next CSP, either we can add restriction if the environment is demanding, or we can relax on the restrictions again if the environment is demanding. So the change takes place due to the variations in the restrictions over the variables. It can be additions or removals. The information in original formulation of the problem is made use of for refining the subsequent ones. We may be having original format or formula for the problem. It is used for the refinement. Refinement means we will be making the changes when we travel from 1 to 2, 2 to 3 and finally to 5. We have made a series of changes to make different CSPs and finally get to the original problem. So this process is known as refinement. So we will be using the original information, and we can add or subtract restrictions and go on making changes, and finally we get to the goal of the 5th static CSPs. Altogether they will be forming, that is, many static CSPs will be forming a dynamic CSP. I hope you are getting it. These DCCSPs can be classified into 3 types based on the method of change of information. Because when the environment changes, our heuristics also changes and the corresponding constraints also get changed. With these changes, we can have different type of DCSPs. They are called DCSP classifications. One is oracles. Here it means that the solutions found in earlier CSPs, we know that this is a series of static CSPs, and on completion of each static CSP, we will be having incompleted solutions or partial solutions, because we will be getting only the final goal will be achieved only after completion of the final CSP. So solution found in the earlier CSPs or partial goal, it is made as the heuristic or information to the next CSP. Suppose our current CSP is the third one. So the information got from the first, then from the second will be treated as the heuristics for the movement of or advancement of current CSP. The solution found in earlier CSPs in the series are made use of as heuristics to guide the present CSP from the beginning. That is oracles. Next one is local repair. Every CSP is computed beginning from the incomplete solution of the earlier one. As I said, on each completion of the static CSPs, we are not getting into the final goal. So we are having only partial solutions in each of the CSPs. So the solution is incomplete if we view from the single static CSPs. So we'll be making changes in one CSP to generate the next CSP. So we can consider the whole space, problem space, as two components. One is the global space containing, say with our example having 5 CSPs. All these 5 put together will have the global space, and for each of these CSPs, static CSPs, they will be having local spaces. So the repairing is done on the local space to move on to the next space. What is meant by repairing? We are adding or removing restrictions based on the requirement of the environment in which that portion of the problem is situated. That is called repairing. Since it is done on the local area for generating the next CSP, we call it as local repair. Okay. And the final one is constrained recording. We may have to make new conditions because as the environment demand is going on changing, we may have to rethink of the conditions. We may have to add new conditions or remove some conditions. Such removal or changes in the conditions are recorded. So new constraints are defined at every step of the search for representing the learning of varying group of decisions. So as the solution proceeds, we may have to change the conditions regularly because the environment demands such a change for the dynamic constraint satisfaction problem. So that's the final one, constraint recording. Because the constraints are generated newly, they have to be recorded. So these are the DSP, CSP classifications: oracles, local repair, and constraint recording.